All right, so we're going to do a little bit of a factoring review. So this is stuff from chapter P5, section P5, I should say. In the book, this is classic MA 120 stuff, classic algebra stuff, factoring polynomials. It's one of those math techniques that sort of never goes away. You're going to use it in almost all the math classes you do once you've learned it. We're going to kind of roughly go book order, not entirely. We're trying to do this a little bit faster again, just as a review. All that stuff in the book, of course, is still there in any event, so you can pop back and check that to get a little more detail. What we're going to start with first is the idea of factoring by grouping. I think technically the first thing in the chapter is they talk about factoring out a GCF. Factoring out a GCF is part of factoring by grouping, so we'll sort of review the GCF just as a part of this example. So factoring by grouping, we're going to use this for polynomials I'll say with 4 terms. So for example, something like 3x cubed minus 2x squared plus 9x minus 6. So the idea here, right, is that you have, right, kind of 1, 2, 3, 4 individual terms. And so factoring by grouping is the idea that if you sort of look at your whole polynomial, you can kind of always from the very beginning look at your polynomial and see if there are any common values you can pull out. Is there a GCF across all of the different terms, no matter how many you have? In this case, 4 terms, and there are no common numbers. They're close, right? I mean, 3 and 9 and 6 all have 3, but then the 2 kind of spoils it. Obviously, then 3 and 2 are not so compatible. You could look for common x values, but we go from x cubed all the way down to a constant term, so there's no way to factor out any sort of x terms from all 4 of these terms. So factoring by grouping is a matter of saying, okay, well, let's if we can't sort of get anything in common across all of our terms in the polynomial, let's group it into pairs. So the sort of default is really just to do sort of first 2, last 2. And what we're going to do is we're going to look for the GCF only across those pairs. So this is a much smaller amount to work with, and for the most part, we'll have much better luck trying to get a GCF out of fewer things. If we do that, we kind of already said for the first 2, 3 and 2 don't have anything in common, but we do have a lot of x's in common, x cubed and x squared. So we can always sort of factor out whatever the smaller number of x's is here, 2 x's. So I'm just going to put that GCF out in front, and then whatever is left over, I'll mark some parentheses, and our leftovers are going in our parentheses. So if I have x squared factored out, that's going to leave me with the 3, and then x cubed. If 2 of those x's come out in front, then there's 1x left over. From 2x squared, well, obviously x squared is coming out, so there's no x's left. That just leaves us with the number 2. And then as far as the sign in the middle, we're sort of just factoring out a positive x squared, so everything on the inside will stay. So this is still going to be minus 2. So this is x squared, and then this is 3x minus 2. For the second pair, we're going to do the same idea. Now we kind of have the opposite situation where we don't have enough x's in common, 1 x here and then no x's here, so we can't pull out any x's, but we do have some numbers in common. 9 and 6 both have 3 as a factor, so I can take a 3 out in front, parentheses, right, what's going to be left over. To a certain extent, we need to decide a little bit on the sign of this 3. My kind of general rule is if this third term, if this is a positive term, so positive 9, let's pull this out as a positive 3. I think for the most part that works pretty well. The goal is going to be to try to get whatever's in your parentheses here and here to be totally in sync, numbers but also signs. In this case, if I do 3 out of 9x, I'll be left with 3x, positive, positive, positive 3x here. So that's a pretty good indication we're on the right path. If I do positive 3 out of this 6, I'd be left with a 2. If I take out a positive, then this stays minus. So the minus here and the minus here are both in sync. So the idea is I'm just sort of rewriting this using this sort of selective GCF factoring. I'm doing first 2, last 2. This obviously kind of only works if we have 2 and 2, these sort of like pairs of terms, 2 and 2. If we have 3 terms, for example, we can't necessarily jump right to this step because we're imbalanced. Once we've done this, well, so then it's a matter of saying, okay, so the idea is 3x minus 2 and 3x minus 2. These guys match. And so in some sense, mentally what we're thinking is this is now like a common term. This is sort of a common expression. So the idea is I have 3x minus 2 as something that's common to both of these like larger expanded terms. And so then if in some sense I factor that out to the right, what my leftovers are my pieces here in red. And so I can make a new parentheses with my pieces in red. So in this case, the x squared, my GCF from the first pair, and then my plus 3, the GCF from the second pair. So my final version here, my factored version, if I sort of just write this in one color, so x squared plus 3 times 3x minus 2. So factored up and ready to go. And that's factoring by grouping. So we've got some GCFs in there, and the idea is we're trying to take this sort of individual term by term expanded polynomial and sort of rewrite it, break it down, and sort of rewrite and combine it into a product of 2 smaller, simpler, shorter polynomials. So we're trying to take all this like addition, subtraction with all these individual terms and then combine it and sort of rewrite it to compress it into this like multiplication, this product of these shorter polynomials. That's the basics. So factoring by grouping.